Hey everyone, ever wonder why your phone's camera app can recognize faces in a blurry photo, but struggles to track your movements in a fitness game? That's the tricky problem we're tackling today. How AI models can see clearly no matter the image quality. Let's break it down. So here's the setup. Imagine a group of artists painting the same scene, but some are using high-resolution canvases and others are working on tiny, pixelated screens. How do they all end up with the same masterpiece? That's the challenge of federated learning, a method where AI models learn from data across devices without ever seeing the raw data itself. It's like a global art collective, where each artist shares their techniques, not their materials. But here's the catch. Most AI research has focused on classification tasks, like telling a cat from a dog. What happens when we ask models to do something trickier, like tracking human poses? Think of apps that follow your movements during a workout or video games that read your gestures. These tasks need spatial precision, not just labels, but exact positions of body parts. The problem? Resolution drift. Picture this, some artists use 4K monitors, others work on grainy smartphones. When they share their techniques, the model gets confused. It's like trying to follow a recipe where some steps are detailed and others are blurry. In technical terms, the model's vision becomes biased toward the resolutions it's seen most. If it's trained on low-res images, it might miss the tiny details in high-res ones. And this isn't just about labels, it's about accuracy in tasks that rely on fine details. So how do we fix this? Enter Resolution-Adaptive Federated Learning, RAF. Think of it as a smart art technique. Instead of just sharing paintings, artists teach each other using heat maps, visual guides that highlight where the important details are. Here's the magic. High-res models, the teachers, share their knowledge with low-res ones, the students. It's like giving a beginner painter a detailed sketch, while also showing them how to adjust it for a smaller canvas. The results? In experiments, RAF boosted accuracy by over 25% when tested on low-res images. Even better, it worked seamlessly with existing federated learning systems, like those on your smartphone or smartwatch. And the implications? This could revolutionize fields from medical imaging, where doctors need precise details, to self-driving cars that must spot pedestrians in all lighting conditions. But here's the bigger picture. Federated learning isn't just about privacy. It's about adaptability. Imagine your smartwatch, fridge, and security camera collaborating to learn from your habits without sharing raw data. But these devices don't all live in the same world. A smartwatch designed for city dwellers might crash in a rural area, or a health tracker trained on adult data could fail for kids. This is the domain generalization problem, making AI adaptable to any environment. Enter a 2023 breakthrough by Lay and their team. They tackled a big hurdle in federated learning, non-IID data, when devices have wildly different data, like a fridge in a busy kitchen versus one in a quiet apartment. Their solution? A smarter version of FedAvg, the go-to algorithm for federated learning. They called it RAF, Robust Adaptive Federated Learning. Here's the magic. RAF doesn't just average models like traditional FedAvg. It adds a dynamic regularization layer, like a personal trainer for AI. This layer adjusts to each device's unique data, ensuring the model stays sharp no matter the environment. Imagine a tailor who customizes a suit for every body type, not just one. The results? RAF crushed the competition. In one test, it boosted accuracy by 12%. That's like acing a test you barely studied for, while cutting communication costs by 18%, saving energy and data. It's a win for privacy, efficiency, and adaptability. Why does this matter? As IoT devices flood our homes and cities, their ability to learn together without compromising privacy will define the next era of tech. Picture self-driving cars adapting to local traffic patterns, or medical devices tailoring care to individual patients, all while keeping your data safe. So next time you interact with a smart device, remember, behind the scenes, AI is learning collaboratively, securely, and smarter than ever. Thanks for watching. Hit subscribe for more deep dives into the science behind the tech.